even in, excuse me, in 15, x is linear, so a over x. And this is quadratic, it doesn't factor any further. So over it, we need that to have bx plus c over it. And then here's an example where they have 3 linear factors, so they use a, b, and c. So this page can be something you refer to as you try to set things up. So our 7.4 day 3 then examples, and then there's one more on the back that I forgot to copy off that we need to do. All right, so what is the partial fraction decomposition? Well, the first thing is you need to completely factor the denominator. So you need to completely factor before you break it apart. And these are both linear factors. So you're going to have a over x plus 2 plus b over x plus 4. And then you multiply each side by the LCD. And that means every term. And that should clear out the fractions. And that goes away, the x plus 2 cancels, the x plus 4 cancels. So that's a nice thing to get rid of all the fractions. Now, on the right-hand side, you need to expand. And then we have some like terms, the ax and the bx need to go together. And the other 2 terms are considered our constants. And then factor out the x. And I write it at the back. And then we equate coefficients. The a plus b has to equal the 1x. And the 4a plus 2b are your constants. They have to equal 8. That's called equating coefficients. That's the only way they can be equal. If a plus b is 1, and if 4a plus 2b equals 8. So here's equation 1, here's equation 2. And then you have so many choices. You can use substitution, elimination to solve it. I'm going to come up here and I'm going to take equation 1 times a negative 2. And then we add. And we get a is 3. And then I'm going to substitute a equaling 3 into equation 1. And we get b is negative 2. But you need to keep going. unlike the worksheet where they broke it up, you could just stop with to know if you're right with what A equaled and what B equaled. But you might have factored this in the opposite order and had A over x plus 4 and B over x plus 2, and then my A is your B and your B is my A. So, but if we all put it back into there, A is over x plus 2, so 3 over x plus 2. And with B being negative, I'm going to put the negative here and have the 2 be positive over x plus 4. So instead of addition, it's subtraction, and that's the same as plus a negative 2 over x plus 4. But it's more common to just put it that way. You need to do that. You need to go all the way to substituting them back in. If you only leave it where A equals 3 and B equals negative 2, you will not get full credit on these because of the fact that it wasn't set up for you. So, on the next one, again, completely factor the denominator. You do not need to factor the numerator, even if it does. And that's all you can do is take out an x. X squared plus 9 does not factor any further. So you have a linear and a quadratic, so we're going to do A over x plus bx plus c over the x squared plus 9. And then multiply everything by the LCD, which is keeping the equation balanced by multiplying both sides by the same thing. And that clears out the fractions. Expand, collect like terms. And then we are going to collect like terms, and I'm okay if you pull out that x squared right away. Noting that it's going to be the quantity a plus b times the x squared. And then we just have a cx and a plus 9a. And so, equating coefficients, a plus b must be 5. And c, c must be a negative 1. And a is over x, so it's 3 over x. And then we have bx, so 2x, and then c is a negative 1. And that is how your final answer needs to be presented. Because you need to go back here and plug in a, b, and c for your final answer. All right, and then on the back side, there's another example that didn't get included here. So x squared minus 4 over x to the fourth minus x. And while x squared minus 4 factors, you don't factor the numerator. It's the denominator that you need to factor. And when you pull out the x, you have an x cubed minus 1. And you need to remember how to factor a difference of cubes. It's a binomial times a trinomial. The binomial has the same sign. And then you square this. You multiply, take the opposite side, do not double. So x cubed minus 1, binomial is x minus 1, x squared, multiply opposite sign, and square the 1. And now we're ready to break it up. And you have two linear factors, so you have an a over an x plus b over x minus 1. And then plus x squared plus x plus 1 is quadratic. It doesn't factor any further. You have to have a cx plus d. And then you multiply each of these by the LCD. All right, so now it'll clear out the fractions. And a is left times x minus 1 x squared plus x plus 1. So this just takes a little perseverance, trying to be careful as we go through, trying to not make errors. Oh, and now we get to expand and collect like terms. Now, do yourself a favor, hopefully. These two factors are what we got when we factored x cubed minus 1. So if I remultiply them, it should just multiply to be x cubed minus 1. But it takes that recognizing, oh yeah, that's what that came from. And then the next one isn't too bad because you're just distributing a single term. And then I'm going to do the binomials first, and I need to distribute the cx. And then distribute the d. And collect like terms, take out the variable. And so we get an a plus b plus c times x cubed. We have some x squared terms. So we have a b minus c plus d times x squared. And then we have bx minus dx. And then lastly, we have a minus a. And then we're ready to equate coefficients. And there is no x cubed over here. That means if I add a, b, and c, they must be 0 because it takes out that x cubed term. So a plus b plus c must equal 0 because there is no x cubed on the other side. However, with the b minus c plus d, there is a 1x squared, so they must add up to 1. And with b minus d, there is no x term, so b minus d must be 0. And the opposite of a must equal the opposite of 4. And there is your system. 4 relationships, 4 variables. We should be able to solve for all of them. And this one right here tells me that a is 4. And this one leads me to b equaling d. And so what you want to do is use this information with the other 2 relationships and get them to have the same 2 variables so you can solve. So it takes a little problem solving to do that. The a part's easy because a is just 4. But with the b equaling d, you either need to replace the b's with d or this d with b. Since if I replace this d with b, that's only one substitution, that's what I'm going to do. But the goal is to use this information and get these down to the same 2 variables. So if I call this 3 and this 4, I'm going to substitute equation 4 into equation 1, and I'm going to substitute b equaling d into equation 2. And then that leaves me with But you have to be careful. Like I said, with the B and the D, you choose to go one way or the other. If you swap them all out, then you're going to still not have 2 equations with the same variables. And now we have B plus C equals a -4, and 2B minus C equals 1. And then if you add, you get b as a negative 1. And since that b and d are equal, d is a negative 1. So you know a, b, and d, and you just need to find the value of c. And so you can go back to any of those that you want, but I know b plus c is a negative 4, and b is a negative 1. And I get c as a negative 3. So over here, I have a is 4, b is negative 1, d is negative 1, and c is negative 3. And now we're going to go way back here and replace them in here. So a needs to go over x. And then b needs to go over x minus 1. And then we get cx plus d. So a negative 3x minus 1 is over this x squared plus x plus 1. But we don't leave it with the negatives in the numerator. We come out here and make that subtraction. And you have to be careful on this one. You have to take the negative out of both. Both signs have to change. And so it's minus a positive 3x plus 1 all over this. And that ends the notes.